Hello, my name is Simon Pongtawongsa. In this video, I'm going to do the experiment in Tinkercad for the experiment number 5, power factor and time constant. In this experiment, there are 3 parts. So let's get started to do the part 1 of the experiment. Part 1 of the experiment, we need to have the breadboard and also a capacitor and a resistor. A capacitor and a resistor are connected in series. The value of the capacitor initially set to be 4.7 microfarad and the resistor 100 ohms. So now we have this. We need the source. We did use this one. So we connect this. We need to measure the voltage across the resistor. We need to set this first. 100, 120, 10, 0, and this sign. So this is 10 millisecond and the voltage division is 4 volt. And we need to measure the voltage across the capacitor. So this is the output of the oscilloscope. So if we want to know the voltage across this resistor, we can count this little square from this peak to this peak and then multiply by 4. So we should get the voltage across this resistor. And for the period, we can count for a complete circle where this line starts until its end of the circle. It's here, this point. So we can count 1, 2, it's 2. It's almost 2, and then multiply by 50 milliseconds. This should give us the period. And for the frequency, we can set it to be 1 divided by its period. So that should be the frequency. So it will be the same as for the capacitor in this case. It's the calculation process will be the same. So this is for the part 1. And now we also need to change the capacitor from 4.7 to 10 microfarad. To 10 microfarad and measure its value again. So this will be like this. The amplitude, this one is higher than, the amplitude of this capacitor is much higher than the resistor. And as the result, the voltage of that cross the capacitor would has greater value than the voltage across the resistor. So let's go to the simulation of part 2 of this experiment. Part 2 of this experiment, we need to have a capacitor which is 4.7 microfarad and a resistor of 3.3 kilo ohms. And this set to be 1000 sine. Ten milliseconds. Okay, this is the measurement of the voltage across the capacitor and the voltage across the resistor. Here the voltage division is 20 and the time per division is 1 millisecond. So if you want to know the voltage across this resistor, we can count peak to peak voltage and multiply by 20. That should give us the voltage across the resistor. For the time period, we can start to count from this circle, from the beginning to the end of this circle. 1, 2, 3, 4, 5. That should give us 10 multiplied by 1000 microfarad. second. That should give us the period. And for the frequency, we can set to be 1 divided by its period. It's the same also for the capacitor. But this one, we have to multiply by 200 millivolt, and this 1000 microsecond. So we set this to be, we can train the value for the second one of this part. We train the capacitor we replace this with Henry inductor. Yes, we replace this. The value of this inductor is yes, this is the outcome of the measurement from the inductor and capacitor. So this, the voltage division is 20, and the time per division is 1 millisecond. And also this one time per division is 1 millisecond. And voltage per division is 1 voltage. So this is the simulation of part 2 of this experiment. So the last part of this experiment is to study the behavior of capacitor and resistor. So let's move to part 3. In part 3, we need to have a resistor we have here, and we train it to be 3.3 ohm. And we replace the inductor with capacitor. And they are connected in series. Its value set to be and this set to be 5, this one to be 500 hertz, and the wave is square wave. In this part of the experiment, we will measure the source, and this one to be black, and also this red part. And this we want to know, we want to see the graph of this capacitor. So now let's simulate this. Okay, maybe we can change this to be 1. Okay, here is the result of this experiment. So when the voltage pass to this capacitor, it will try to resist or slow down the current. Once the no current pass to this capacitor, it will release its energy. When it's released, it will have the minimum value, but when it charged, then it will store the energy as the graph here shown. It will reach its maximum storage, and then it will decrease again when there is no current or voltage run through the circuit. And it's different from this source. This source, when there is current, it will increase, immediate increase vertically. And when there is no current, it will decrease immediately. So it will be vertically direction, and the capacitor will behave like the storage tank of the water. So we can fill the water to the tank and then let the water go down. It will decrease to its minimum, but then when we input or insert water again, and then its storage capacity will increase to its maximum. When we turn off the tap, the water will run out slowly until it die out, and then we charge it again. So basically, this capacitor behave like storage tank of the water. And here we can find the value of the voltage that across this resistor from this oscilloscope screen. We can multiply by 10 voltage, and this one time per division is 10 millisecond. So that's it for the simulation of this experiment 5. Thank you very much.